Well, student, today I am going to tell you about hybridization. How to determine the hybridization of central atom in an inorganic molecule and how to determine the hybridization of carbon atom in an organic molecule. So, stay tuned with me till the end of this video. Let's start with our topic hybridization. So what is meant by hybridization? Hybridization is actually the phenomenon of intermixing of atomic orbital having slightly different energies to form a set of new orbital having equivalent energy and directional property. So what does it mean? Suppose in the third cell means n equal to 3. Now when n is equal to 3, L can have the value 0, 1, 2. Now when L is equal to 0, it is S subcell. When L is equal to 1, it is P subcell. When L equal to 2, it is D subcell. Now under S subcell there is S orbital, under P subcell there is P orbital, under D subcell there is D orbital. Now under third cell it is 3S, 3P and 3D. Now 3S has only one orbital, 3P it is PX, PY and PZ orbital. In case of D, it is having 5 orbital. That is dxy, dyz, dzx and dx square minus y square, dz square. So all these orbitals are there. These 3s, 3p, 3d orbital are there. The intermixing of these orbital to get a new set of orbital having equivalent energy and directional property is called hybridization. So when, for example, one s orbital mixed with one p orbital, it will give sp hybrid orbital. Now one s orbital combined with 2p orbital, it will give sp2. When one s combined with 3p orbital, it will give sp3. A maximum of 3p orbital is possible, that is px, py, pz. Now when s combined with 3p and after 3p it will come 3d. 1d orbital, it will give sp3d hybrid orbital and so on. Now in the first case, since only 2 orbital is combining, you will get 2 hybrid orbitals. Here 3 orbitals are combining, you will get 3 hybrid orbitals. Here 4 hybrid orbitals are combining, you will get 4 hybrid orbitals. Here 5 orbitals are combining, so you will get 5 orbitals, 5 hybrid orbitals. So let's start with our main topic, that is how to determine hybridization of the central atom in an inorganic compound. Hybridization of central atom in inorganic compound. Okay. Let's start with the first example, BeCl2. Now beryllium, what is the electronic configuration of beryllium? Beryllium, the atomic number is 4. So the electronic configuration is 1s2, 2s2. So in the valence shell, it has only 2 electrons. Now in the calculation of hybridization, we will use VAC-PR theory. So if you know VAC-PR theory, then it's okay, very good. And if you don't know, then you can go through my previous video on VAC-PR theory so that it will be easy for you to understand hybridization. Now in case of BeCl2, we have to calculate VSEP, valence shell electron pair. That means how many electron pair are there in the valence shell of the beryllium atom. So beryllium, the valence shell contain how many electron? 2 electron. So half into 2 electron. Now how many monovalent atoms are there? 2 monovalent atoms. Chlorine are monovalent. So we will write plus 2. So it will give 2 electron pair. Now since there are 2 electron pair, we know the orbital are written like this, and in a orbital a maximum of 2 electron can be accommodated, that 2 in opposite spin. So to accommodate 2 electron pair, how many orbitals are required? 2 orbitals are required, and that can be obtained from S, P, D. So we'll start from S and we'll move towards D. Now hybridization will be SP. Why it is SP? Because we need one S orbital plus one P orbital. So it is giving SP hybrid orbital. Hence, the hybridization of the beryllium atom is SP, and the shape of the molecule is linear. Next, move to our second example, that is BF3. Now again we will calculate the VACP, valence shell electron pair, in the beryllium atom. Let's take the next example, that is BF3. Now we have to calculate the VACP. This VACP for BF3 is half. For boron, it contains 3 electrons in the valence shell plus 3 monovalent atoms, so 3. Because boron, the electronic configuration is 1s2, 2s2, 2p1. So it contains how many electrons? 3 electrons in the valence shell plus 3 fluorine atoms, so 3. It gives 3 electron pair. Now to keep 3 electron pair, we need 3 orbital, one s orbital, another p orbital, another p orbital. So it will give sp2 hybridization. And the shape of the molecule will be trigonal planar. Next, move to our third example, that is CCl4. Now again the VSEP calculation is half 4 plus 4, because carbon, the electronic configuration is 1s2, 2s2, 2p2. So it contains 4 electrons in the valence shell. So it is coming out to be 4 electron pair. Now this 4 electron pair can be accommodated in 4 orbital, one s, one p, second p, third p. So it is giving sp3 hybridization. And the shape of the molecule is tetrahedral. Next, move to our fourth example, that is PCl5. Again you have to do the calculation VACP, and that is equal to half 5 plus 5, and it will give 5 electron pair, and so we need 5 orbital, and 5 orbital, that is 1 s orbital, 3 p orbital, so total 4, and 1 d orbital, sp3d hybridization. And the shape of the molecule is trigonal bipyramidal. Okay. Next example is the fifth one, that is SF6. Again, in SF6, VSEP calculation half 6 plus 6, so it is 6 electron pair, because you know the sulfur electronic configuration is valence shell, it is 3s2 3p4, it contains 6 electron in the valence shell. Now to keep 6 electron pair, we need 6 orbital, that is sp3d2, total of 6 orbital, 1s 3p and 2d, so it is sp3d2 hybridization. And the shape of the molecule is octahedral. Next, move to our sixth example, IF7. Now VSEP is half 7 plus 7, because iodine contains 7 valence electron, because iodine belongs to halogen family. So it gives 7 electron pair. Now this 7 electron pair can be accommodated in 7 orbital, that is sp3d3 hybridization. And the shape of the molecule is this is called pentagonal bipyramidal. Now I will tell you how to determine the hybridization of the carbon atom in an organic compound. So hybridization of carbon atom in organic compound. Our first example is CH3CHO. This is called ethanal. It's an aldehyde. So what you have to do, you have to write down the structure like this: H, C, H, H, C, double bond O, single bond H. Now to determine the hybridization, we have to calculate the number of sigma bond. Now how to know which are sigma bond and which are pi bond? The simple way is, in any multiple bond, one is sigma, rest are pi. One is sigma and rest are pi. So for this carbon, it is forming 1 sigma, 2 sigma, 3 sigma, 4 sigma. To form 4 sigma bond, it needs 4 orbital, and that 4 orbital can be obtained by mixing 1s, 1p, 2p and 3p. So total of 4, and hence the hybridization is sp3. Now this carbon is forming 1 sigma, 2 sigma. Now this is a multiple bond. So in a multiple bond, 1 is sigma, rest is pi, so 1 is sigma. A total of 3 sigma bond it is forming: 1 sigma, 2 sigma, 3 sigma. So the hybridization is S plus P, that is sp2. So the hybridization of the two carbon atoms are different. Now move to the next molecule, CH3COOH. This is ethanoic acid. So again we will write the structure like this: This carbon is forming 1 sigma, 2 sigma, 3 sigma, 4 sigma. So the hybridization is sp3. This carbon is forming 1 sigma, 2 sigma, 3 sigma. So again it is sp2. Now our third molecule is CH3 C triple bond N. This is called ethane nitride. Ethane nitride. So again we have to write the structure like this. Now this we know by now 1, 2, 3, 4. So it is sp3. And this carbon is forming 1 sigma bond and 2 sigma bond, because in a multiple bond 1 is sigma, rest are pi. So it is forming only 2 sigma, and to form 2 sigma we need 2 orbital, that is s plus p, and that is sp. Our fourth example and the last example is H2C double bond CH2. This is called propane 1 Our next example is 1,2-propadiene. 1,2 propadiene. So the structure is H2C double bond C double bond CH2. So again we will write the structure like this. Now this carbon is forming 1 sigma bond, 2 sigma bond, 3 sigma bond. So the hybridization is sp2, because we need 3 orbital, 1 s, p plus p. 3 orbital, it will give sp2. This carbon, it is forming 1 sigma, 2 sigma. So the hybridization is sp. This carbon 1 sigma, 2 sigma, 3 sigma. So again the hybridization is sp2. Our fifth example is benzene. What is the hybridization of all the carbon atom in benzene? So we have to write like this. Benzene, the formula is C6H6. So it is having C6H6 and alternate double bond. Now calculate the number of sigma bond. This carbon is forming 1 sigma, 2 sigma, 3 sigma. So the hybridization is sp2. This carbon 1 sigma, 2 sigma, 3 sigma. Again sp2. This carbon 1 sigma, 2 sigma, 3 sigma. sp2. So all the carbon atom is sp2 hybridized. So all the carbon atom is sp2 hybridized. Sixth example is, say, ethyne, HC triple bond CH. Now ethyne, H single bond triple bond CH. So this carbon is forming 1 sigma, 2 sigma. So the hybridization is sp. This carbon is also forming 2 sigma bond. So the hybridization is sp. Hope you understand all this hybridization, and now you can easily do the hybridization of all organic compound. At the same time you can do the hybridization of all the central atom in inorganic compound. And If you are benefited through my video, then please do share my video, like my video, and please subscribe my channel so that you will get informed whenever a new video is uploaded. Thank you.